Okay, so let's look at examples of cumulative change, cumulative discounts. So you and a friend are eyeing a jacket at Old Navy. The original price was $100. However, there is a store markdown of 40%, and there is an internet coupon you can use for 20%. So we have a markdown of 40 and another percent off and another 20% off. What is the final price of the jacket? What is the cumulative markdown? Okay, so I know that if I start with a $100 jacket, if it's a markdown of 40% off, that's 0.40. That makes my factor, a decay factor. 1 minus 0.40 is 0.60. Okay. If I have a 20% off, okay, then that means that's my R, and so 1 minus that is my factor, which is 0.8. Okay, so this is one factor, the decay factor, and this is my other decay factor. So I have this $100 jacket. It is marked 40% off, so I'm going to multiply it by the factor of 0.6. Okay. And so that's easy to do, but just in case there's a question. All right, 100 times 0.6 is 60. And then I'm going to now take that, it's marked down to $60, and I'm going to take that $60 and I'm going to mark it down another 20%, so I'm going to multiply it by the factor of 0.8. Okay? So 60 times 0.8 is 48. Okay? Now remember that the reality is I took $100, I multiplied it by 0.6, and I took that answer. So I took this answer here, whatever it was, and I really multiplied that by 0.8. So I could do this all at one time, and I could just say, okay, 100 times 0.6 times 0.8, and I would get straight up 48. That's the sale price. And what that does for me is that right here, these two together are my cumulative factor. So let's see, 0.6 helps if you 0.6 times 0.8 is 0.48. 0.6 times 0.8 is 0.48. That's my cumulative decay factor. Remember, that's 1 minus R. So therefore, it was a 52% decrease in the price of the jacket. Okay, so the cumulative markdown was a 52% decrease, a 0.48 cumulative decay factor, and a $48 sale price. Let's look at another example. A stunning $2,000 gold and diamond necklace. Over several weeks, this is what happened to it. 20% off the list price. That's the price that it was marked. 30% off the marked price then. And then an additional 40% off all items in the store. So this item is going to be marked down even more. What is the final price of the item? What was the cumulative discount earned? So, what happened to it? This here is the original price. So this is the original. We have a 20% off, a 30% off, and a 40% off. So if a 20% off, that's 0.2, that means my decay factor is 0.8. A 30% off is 0.30, which means my decay factor is 0.70. Remember, decay factors are 1 minus my rate. And then in 40% off is 0.40, so my decay factor here is 0.60. So we have a $2,000 necklace that was marked down 20%, so I'm going to multiply that by 0.8, the decay factor. Then it was marked down by another 30%, so I'm going to multiply it by that 0.7, that next decay factor. And then it was marked down by another 40%, so I'm going to multiply it by the last decay factor. And this is why I want to use factors, because this is a whole lot easier. It would be many, many steps of multiplying and subtracting if I didn't use this. Plus, that right there gives me my net or cumulative decay factor, which will help me find the total cumulative discount I got. So, let's see if we can figure this out. Go back to my trusty calculator. I have 2,000 times 0.8 times 0.7 times 0.6. And it says that the price of that $2,000 necklace is now $672. That's the sale price. Now, I could use that as the new, that as the original, and go back and solve for the cumulative factor. But right there is my cumulative factor that I said. If I clear this out, and I take 0.8 times 0.7 times 0.6, that product is 0.336. That is my cumulative decay factor. So overall, that's what I'm multiplying by. Well, 1 minus r is that number. So 1 minus 0.336. So my discount is 0.664, or actually 66.4% overall. That's my cumulative discount. So my cumulative discount is right there. A third example. Your fast food franchise is growing. You had 120 employees statewide last year. So you had 120 employees last year. This year, you opened several additional locations and increased the number of workers by 30%. Increased by 30%. With demand so high, next year you will open stores nationwide and plan to increase your roll by another 50%. Okay? So, what do we have? We have last year you had 120. This year you opened several additional locations and increased your work by 30%. So this year you increased this by 30%, went up by 30%. Okay? Well, if you go up by 30%, that's a growth factor of 1.30. Next year, you plan on opening more stores nationwide and increasing your roll by an additional 50%. So you're going to go up another 50%. So that's a growth factor of 1.50. All right. So we want to find the workforce this year. So I want to find this number. Then I want to find it next year, that number. And then I want to find the net or cumulative percent increase in work over 2 years, force over 2 years. So I need to find these individual numbers. Okay? So the first one is 120 times 1.30, because that's the growth. Okay? So I can do that. Let's do that. 120 times 1.30, 156. So 156 people or employees this year. Next year, I will be having 156 times a 1.50 growth factor. So I'm going to take that 156, I'm going to multiply it by 1.50, and now I'm going to have 234 people working, 234 employees. Okay? Now, what is your net or cumulative percent increase in the workforce over 2 years? So I could do this two ways. I could say I started with 120. This was my original. My new is now 234 after 2 years, and I could solve for my factor using new equals original times factor. But I already know what happened. I know there was a 30% increase, so there was a growth factor of 1.30 and another growth factor of 1.50. So if I just multiply those two, I get the cumulative growth factor. 1.30 times 1.50 says that there was a cumulative growth factor of 1.95. This is my cumulative growth factor. Well, take away 1, that's a 95% increase over 2 years. Almost a doubling. My workforce increased 95% over 2 years.